This is the third mini lecture for section 13.2 of the textbook. Now we're going to talk about measures of variability. How do we measure how spread out a data set is? How do we describe the shape of the data in the middle? How can we quantitatively talk about data set S being really compact, but data set T being really scattered? Okay, so the first attempt we might make at measuring the variability of data is to just use the range. The range is the difference between the highest and lowest values. Okay, so it just tells you, without really saying anything about the shape of the data, how spread out is it? Like, what's the highest score, what's the lowest score, and what's the difference? The mid-range is the average of the two extreme values. So for example, for the data set R, the range is the difference between the highest and lowest values. That's going to be 92 minus 46. And we get happens to be 46. And then the mid-range is the average of those two. 92 plus 46 divided by 2. Comes out to 69. Okay, but the range and the mid-range have limited usefulness because they don't tell you anything about how the data is shaped in the middle. Okay, all we're seeing is the two extreme values here. Okay, so let's talk about using ideas related to the median to describe the shape of the data. So let a collection of n data values be written in order of increasing size. If n is odd, write n equals 2r plus 1. If n is even, write n equals 2r. So basically that number r is the quotient when you divide n by 2. So in either case, the lower quartile is the median of the first r of data values. The upper quartile is the median of the last r data values. So let's find the lower and upper quartile for the data set R. Okay, so to do this, I need the data set to be listed in order again. And I'm just going to copy down what I had before. 46, 61, 63, 67, 70, 71, 71, 72, 72, 72, 74, 76, 76, 76, 77, 77, 77, 77, 79, 79, 79, 81, 86, and 92. Okay, so the n here is 24. That means that the r is 12. Because n is even, I divide it by 2, I get 12. And the lower quartile is the median of the first r data values. So let me bracket those off. And I compute the median of that set. Gets 12 scores, which is even. That means I'm going to be averaging the two middle scores of this set of 12. 1, 2, 3, 4, 5, 6, and 7. So I'm going to be averaging those two. But they're both 71. So lower quartile, 71 plus 71 over 2, which is 71. Okay, now for the upper quartile. I need to use the last 12 scores. And I take the median of that set. Okay, so it's the average of 77 and 79. And we get 78. So the lower quartile is 71, the upper quartile is 78. So basically, if you think about the median as being halfway through the data set, the lower quartile is a quarter of the way through the data set, and the upper quartile is 3/4 of the way through the data set. Okay, the interquartile range, or IQR, of a data set is the difference between the upper and lower quartiles. So the IQR is QU minus QL. An outlier in a data set is a data value that lies outside these two numbers, the lower quartile minus 1.5 times the IQR and the upper quartile plus 1.5 times the IQR. So let's find the IQR and any outliers for the data set R. Okay, and you're looking for outliers. Remember, you could have one outlier or many or none at all. So, anything is possible. Right, so the data set R, remember we had lower quartile was 71, upper quartile was 78. So the IQR, the interquartile range, is 78 minus 71, which is 7. So that's part of the answer. Now we want to see if we can identify any outliers. So first I need to do lower quartile minus 1.5 times the IQR. So that's going to be 71 minus 1.5 times 7 is 10.5. So that's 60.5. Okay, upper quartile plus 1.5 times the IQR. That's 78 plus 10.5, which is 88.5. Okay, these are not the outliers. Okay, an outlier is any score that lies outside of those. And for data set R, I see, let's see here, 60.5. We have a 46, which is below this value. And above 88.5, we have one score, and it's a 92. So 46 and 92 are outliers. Okay, but it's quite possible that you might have just one outlier or none at all. Just remember these two numbers, these are not the outliers. An outlier is a score that lies outside of those two numbers. And there may not be any, or there may just be one at the bottom, or just one at the top, or both, or multiple. You could have two at the bottom and none at the top. It just kind of depends on the data set. So the IQR, basically, it's the range of the middle half of the data. So that's a little bit more of an exact measurement of the spread of the data. You're measuring how packed in is the middle half of the data. And then outliers are scores that are way outside of that. These are the scores that are not typical of the data set, so to speak. They lie way outside the middle half of the data.